Okay, so real quick on this second circle, what's the name of this circle?
L.
It's circle L. Okay, now on this is they're kind of not asked the best, but okay, so there's actually how many radii in here that's drawn? There's actually 3. I mean, they're obviously going for which one do you think?
AL.
AL. The one that's only a radius is kind of what they're going for, but there's also LB, LM. Okay, what's the diameter there?
MB.
Is MB. Okay, you get the idea there. All right, let's go ahead and flip over. And let's just look at this. All right, a central angle of a circle is an angle where, with the vertex in the center of the circle. Okay, so a central angle is one where the vertex is at the very center of the circle. So like this right here, this is an example of a central angle. Okay? Which you may be thinking, well, yeah, I mean, that makes sense. But there's going to be other type of angles. There'll be angles that are what we call inscribed angles that'll be on the edge, and angles that are just floating around out in the middle in general. So, and the math on each of those is different. So it's important to recognize the difference. These are central angles. Okay, so in a circle, I don't know how big angle 1, angle 2, and angle 3 are, but what do you think they add up to, regardless? Good, they always add up to 360 degrees. Okay, so in this one there's 4 angles, but those 4 angles are going to add up to 360. So how am I going to find the measurement of this one?
Add them all up and subtract 360.
There you go. So just add them up, subtract from 360, or the way I like to do is go 360 minus 76 minus 44 minus 98. What does that give you? 2, 8. It's going to be 2. 142? Okay. So that angle right there would be 142 degrees. All right, now. All right, this should say an arc is a portion of a circle defined by 2 endpoints. Okay, a central angle separates the circle into 2 arcs with measures related to the measure of the central angle. So an arc is a portion of a circle, portion of the outside of the circle. Basically, we could say a portion of the circumference. So like from here to here, this is what we call an arc. Which, for that matter, going the other way, we could call that an arc also. It's just a piece of the outside of a circle. All right, so there's different types of arcs. This one is what we call a minor arc. Okay, so a minor arc, 2 things about this. Number 1, the minor arc is the shortest distance between the 2 points. Okay, so like from this point and this point, the minor arc is going the shortest distance between them. And so a minor arc is always going to be less than 180 degrees. Okay, now you can see here we've got this point, and I've got this like bolded or highlighted, whatever. This is going the longest distance between those 2. So if that one's a minor arc, what do you think this one is?
Major.
It's a major arc, yep. So the major arc is always going the longest distance between 2 points. And so it's going to be more than 180 degrees. Okay? And then the other possibility is this one right here, okay? Where either direction is going to be the same distance. All right, and so we just call this a semicircle. What does hemisphere mean?
Half a sphere.
Half of the sphere, half of the globe, right? And semi, kind of the same thing. Semi means half, just like hemi. Okay? Which the hemi, I guess, really refers to three-dimensional. All right. Now, this arc right here, from here to here.
It's a minor arc.
Okay, good. This is going to be a minor arc. And why did you say that?
It's under 180.
It's less than 180. Now, here's the other thing. Going back up to what we talked about, what this said right here, that the arc is related to the measure of the central angle. Not only is it just related, it's the exact same thing. Okay? So if that angle is 120, this arc is 120 degrees. Okay? That's the way it is with central angles and their arcs. The arc is the same number of degrees as the central angle that makes it. So on this one, what type of arc is this one?
What arc is that? Tell me, Adrian.
Is that minor, major, or semicircle? It's a
Noah's arc.
It's Noah's arc. It's a major arc. Now, how many degrees is that arc? Yep, it's more than 180. So exactly how many is it? 220.
The first one should be 102, right?
Oh, yep. Sorry, my bad. That's what y'all are talking about.
Yeah.
My bad. Yep.
I was thinking you moved it 2 over.
I do that all the time. Always moving numbers wrong. Okay, it didn't ask for it, but I want to ask, how many degrees would this arc be on this one?
140.
Okay? Why?
Because that they add up to 360.
Add up to 360. Exactly. Okay? On this one, what's that? Oh, we're lagging. All right, semicircle, how many degrees? Exactly 180 degrees. Yeah, we lagging bad. Come on. All right. On this one, how many degrees is this? What is this? It's a minor arc. How many degrees is it? It would be a 90-degree arc. What about on this one? Okay, it's minor, and it'd be 21 degrees. What's this one? It's a minor arc. How many degrees?
152.
152. Okay, so on the back here, this is asking for the measurement of arc GH. So GH right here. How many degrees would that arc be?
22.
122. And is it major or minor?
Minor.
Minor. Okay, now GLH. Okay, the order of the letters matters here, so we have to go from G to L first and then get to H. So we've got to start here, and then we just keep going that same direction all the way around.
360 minus 122.
Good. What is 360 minus 122? Okay, good. Because if you go all the way around, that's 360. So we're doing 360, but taking this 122 out of it. What does that give you?
238.
Gives you 238. Since some of y'all are here are in music, you may not know the difference in this, but a lot of times whenever people write out like a major and minor chord, like for minor they'll put a lowercase m, for major they put an uppercase m. So that's the way we'll do that. For minor we'll just put lowercase m, and for major we'll put uppercase. All right, and then on GLJ, okay, GLJ,
That's a semicircle, so it's 180.
okay, 180, it's a semicircle. All right, next one is MQ.
It's a vertical angle.
Well, yeah, you're thinking right, but it's not vertical, but it's close. This would have to continue straight on like this.
190, so that means 25.
Is R 90 degrees?
75? Wait. 65.
Okay, how'd you get that?
Subtract 180 and 150.
Okay, good. From M to P is 180, right? That's a semicircle. So if you do the 180 minus the 115, that's going to leave you this angle, which is 65. Okay. All right, next one is MNP. So M to
That's
N, then to P. Yep. That's 180. That's a semicircle. All right, and then on that third one, M, N, Q. So M, N, and then to Q. So you have to get
360.
M to N first,
Oh.
and then around to Q. So it's nearly 360, but with that.
295.
Okay, good. So it's 360 minus the 65, which is 295. And that means, what kind of arc is that? It's a major arc. All right, CE.
That M is confusing.
What do you think?
Minor.
That's equal to F, but it's.
Yes, it would be equal to F. That would be
We
vertical.
have three angles, because
I
there's
got it.
63 across, and then there's the 90.
So this would be 63, yes, just like this one.
63.
Okay, how many degrees is it from C around to A?
180.
180
180.
minus 53.
So it's 180 minus.
Yep.
53.
Semicircle minus 63, 180 minus 63.
Which is 50, 27.
Harder than
It's 170.
117.
Wait.
that.
Oh.
Subtract 90.
There you go.
CD is 27.
I do.
And so that is a minor arc. Alrighty. And then okay, ABD. So A, B, D. We have to go from A to B first and then on around to D. What do you think?
Two is
Okay, I can't remember what it is off the top of my head, but how'd you get to that? What did you do?
because CD is 27, and then 180 plus 27 is 207.
Okay, good. Or you could think about it like this. If you go from A all the way around to A, how many degrees is that?
360.
So it's 360, take off 63, take off 90 is another way you could do it. So 360 minus 63 minus 90, and 207, is that what it is? And is that major or minor?
Major.
That is a major arc. Okay, everything we've been talking about so far is in degrees. Okay, everything so far is in degrees. What does degrees actually mean?
It's an angle measurement, how wide something is.
Yeah, that's true, but like what, I mean, like really, what is a degree?
It's a measurement.
It's a measurement, yes, but there's something specific about it. Like it's going to be something very specific. Not difficult, but something very specific.
An arc.
It's something basically we've already talked about. That's it, okay? What a degree is taking a circle, okay, and splitting it up 360, which this is way not that.
Temperature in degrees.
The degrees in temperature is totally unrelated to these type of degrees. They're totally unrelated.
Adrian.
But that's what this degree is it's taking a circle and splitting it into 360 equal pieces. That's physically what a degree is, okay? So everything we've been talking about so far is degrees. This last little thing we're going to talk about here real quick, which is easy, is not talking about degrees, it's actually talking about the actual length. All right, so here's our formula for arc length. 2 pi r times m over 360. Now, forget about the m over 360. What is this 2 pi r? What
That's
form-
The 2 times the radius times pi.
Yes, what does that give us on a circle?
That
We did this 2 days ago.
circumference.
It gives you the circumference. So that tells you how far it is all the way around. So what arc length does is it tells you the length of just a portion of the outside of the circle. Okay? And so that's why we have the m over 360, because there's 360 total degrees. M is going to be the measurement of the angle. Okay? So the R refers, this R refers to the radius of the circle. The M refers to the measurement of the angle that makes the arc, or the measurement of the arc itself in this case. And the arc length is how long that piece is. So on this first one right here, we want to know the length of zy. So I want to know how far it is from z to y. So we're going to go 2 times pi times, what's the radius on this one? It's 4. Okay, times what's the measurement of the angle that makes it? 75 over 360. Now remember, in your calculator, do not type in 3.14. Use the pi key on your calculator. It's right next to the H down on the keyboard. Make sure you put the pi symbol in there. Use it. Calculator's pi. So 2 times pi times 4 times 75 over 360. What does it give you? 5.24 inches. So what that means is if this circle was actually to scale, if this was actually 4 inches and if this angle was actually 75 degrees, if you were to measure this, it would actually be 5.24 inches from here around to here. Okay? Now, so that's how long it would be 5.24 inches. How many degrees would that arc be?
75.
It'd be 75 degrees like we've been talking about. Yep. Okay? So it'd be 75 degrees, but in actual linear measurement, it would be 5.24 inches. All right, on this last one right here, again, we're looking for zy. So it's going to be 2 times pi times, what's the radius on this one?
5.
Good, because 10 is the diameter, it goes all the way across, so the radius would be half of that. So 5 times 130 over 360.
Wait.
Okay, so 2 times pi times 5 times 130 over 360. What does that give you?
11.34.
Okay, 11.34, is that what you said?
Yes.
Yep, that's what it is. So again, what that means is if this were to scale, if the diameter was 10 and this angle was 130, it would be 11.34 inches around this part of the circle from here to here.